Hello everyone, welcome to another video. Today we're going to look at hybrid functions, and just like a hybrid car is like, part petrol engine, part electric engine. Hybrid functions have different parts to them as well, and you'll see at that example that we're about to sketch, it's got actually three different parts to it. It's got this part, which will be defined for a certain domain. It's got that part, which will be defined for another certain domain, and that part for something else entirely as well. And so the three graphs all go together in one graph, and you'll sort of see what happens in a second. Okay, so that's what we're doing today. The things that we sort of need to be sort of aware of and sort of just be watching for is where they start and finish. So that that first function goes between -3 and 0, and it doesn't include 0, whereas this function is for where it actually includes 0. So just we need to be really conscious of whether it's less than or equal to, or just less than, and you'll see whether it's a solid dot or a hollow dot. You'll sort of see what happens with that in those sort of situations. But anyway, let's sort of get through it. So this is the only example I'm going to do today. I sort of want to sort of go through this, but I'm just going to do each graph one at a time, and just to sort of show you what it sort of looks like. And again, it's pretty rough. I could be doing this with a nice ruler and that sort of thing, but I just want you to get the idea of what's happening in these hybrid functions. So the first hybrid function is x plus 2. And so that's a linear equation. You can think of that as y equals x plus 2. And that has a gradient of 1, because that's 1x plus 2, and a y-intercept of 2. And so what that looks like is it's going to go through 2. And because it's got a gradient of 1, that means it's got a rise over run. And so that means it will also go through -2. And it's going to be the straight line that goes between those two. So I'm just going to draw it in. And what I will do first is just draw it in as a dotted line. Okay, so it's going to look something like that. So that is I'm just going to put a blue dot next to it. That's that blue function. I'm actually pretty proud of how straight that line is without using a ruler. That's go me. Okay, second function that we've got there is we've now got y equals x squared plus 2. And that is a parabola. Y equals x squared, and so y equals x squared looks like that. Y equals x squared plus 2 gets lifted up by 2. And so what that function looks like is something like that. It's a bit rough and a bit gross. In fact, I just can't handle that at all. Bit too, came in a bit steep, I think. Something like that. Okay, so that's what that function looks like, again in dotted lines. Pardon me. And the last function I'll do in black. That's y equals 1, essentially. And so what does that line look like? That's from the point 1, so 1, and so that line sort of goes across like that. That's what the graph of y equals 1 looks like. So they're the three graphs, and I've put them all on there, but we actually need to now go and look at, I'll just put what color, that was green for that one there. We need to now go and have a look at the domain where they're defined for. So firstly, let's have a look at this one. So x plus 2, that's only defined for x between -3 and 0. So let's have a think about this. So it goes between -3 and 0, and that's the blue line. So what it's going to be is, because it's not including 0, there's going to be an open circle there, right? So that's an open circle when x is equal to 0. It's not included on this graph. And the solid line is going to go down. It's going to go down because now the solid line is our actual graph now, okay? So I'm just going over the dotted lines. The dotted lines are just my guidelines. But I want to go back to x equals -3. Now, where do I stop? I need to actually figure out a few things. So for y equals x plus 2, I'm just doing some working out here, x plus 2. If x is equal to -3, then y is equal to -3 plus 2, which is -1. And so we're going to get the point -3, -1 is where this line's going to stop. And so that's roughly about there, okay? And it's including that point. And so that solid line is going to go all the way between there and there. Okay, so that's the blue section that is done now. And I'm going to label that because that's an endpoint, -3, -1 there. Okay, so that goes up, and it doesn't include at the other end that there. That there doesn't include that point because it's not equal to that. Well, good. All right, let's do the next part. The next part, x squared plus 2, so our green section. I'm going to be going over it in blue though, because blue is my final line. X squared plus 2 goes between 0 and 2. And so again, I need to know sort of the, and I'm going to come over to the left, so y equals x squared plus 2. I want to know where it starts and finishes. Okay, now it goes through 2, so it starts at 2. So I'm going to change that to go to being a solid dot now, because that includes 0 there. X starts at 0, so it includes that point. But where does it go up to? So it goes up to when x is equal to 2. So y is equal to 2 squared plus 2, which is 6. And so we're going to be coming out this way, and it's going to go up, and it's going to finish at 2, 6. Okay, so I'll just go up a little bit. Let's pretend it's there. It's probably not as high, but I'm going to run into trouble here. But that's 2, 6. So that's where that graph goes up to. Okay, so that's the second section there. We've just done that section there. So the graph of x squared plus 2 with a domain between 0 and 2 looks something like that. And you'll just notice that because it includes, it's less than or equal to 2, so we've done a solid dot there. You'll see that that dot there is a solid dot because it includes that point. But you'll see what I do next when it doesn't include that point. And in fact, I've already done one where it's just, you do an open dot. The rest of the graph is just down below. And so when x is equal to 2, y is equal to 1. And so what we do down here is we're doing an open dot there. And then from x greater than 2, it just goes on forever, doesn't stop anywhere. So that just keeps on going out in that direction. And so that's the finished graph. I'm just going to take away the guidelines and see if this erase works. I'm just going to erase all the things that are not part of the graph so you can sort of see what the finished product looks like. So I'm just getting rid of all my original functions, and you don't need to do the original functions in there. Just to show you, I just wanted to show you how the hybrid function was built and how to sort of think about it. So I'm just going to get rid of all those bits, and that will be what the hybrid function looks like. What I'd recommend you doing is that when you're drawing them, do them in pencil, like your little guidelines, and then as you go, sort of build the function and erase what you don't need with a pencil. But this is almost finished. Let's just put in some important points there. That point there is 2, 1, and you'll see it doesn't include that. And this line to the right out here, that goes forever, so I don't label anything. There's no end point there, so I don't need to label. And so that is my final graph. Just make sure I've got y and x there. And I'll just label the graph of y equals fx. I'm not going to write the whole hybrid function. That is plenty. And that's my graph. Hope that makes sense. So you're putting together 2 or more separate graphs. Just be aware of where they start and finish. If they include the point, do a solid dot. If it doesn't include the point, do an open dot like I've done there. Hope that makes sense. See you in the next video.